computer, and we are about to start the session. Good morning, ladies and gentlemen. Welcome back. For those that attended the first session, the kickoff session, and welcome for those that just attend the session for the first time and most probably have watched the recording of the first session and even might have played already a little with ZeroOS, installing it, booting it on a virtual device, or even, as I hear, on a physical device. Some of you have been contacting me with questions. Some of you have been contacting me just to say how excited they are that it all worked on their media server. Even there was a guy who gave up his media server to install ZeroOS because he's convinced, and we will support him doing so, that in one of the next sessions he then will be able to create a container running basically the media server. So yes, that will be possible, and yes, I will be supporting these kind of scenarios through all kind of support channels, and of course, most importantly today, Telegram and weekly sessions and sync moments we have on Tuesday and Thursday. Basically, today is a session about booting ZeroOS and playing with the APIs. In a way, you will not learn much more than what I already showed the last time. We will be showing you some extra scenarios, basically booting, for instance, on OVH, booting on QEMU we will show you. We will play a little bit with that. I will be doing some Python interaction, not much more than the other time, but then again, it can help you. And remember, the point of these sessions is more like to have a sync moment, so that we always cover one topic. Like next week, the big topic will be virtual machines. No, sorry, will be containers. And then again, the idea is I do a demo and you try it yourself. Okay. Now the schedule, or what will be covered today, is on the screen. So first of all, I will go over again quickly on the schedule, so just so that you know what we are about to do today and what will follow in the next weeks. I'll do again a quick walkthrough in the repositories, because I find it important that you understand exactly what repository is doing what, and also because we are not, let's say, centralizing all documentation in one repository, but we are rather on purpose putting all documentation in the code repositories. So if we talk about, for instance, the block storage implementation on top of ZeroOS, we will put that documentation in the block storage repositories. Or if we talk about things like the orchestrator, well, orchestrator documentation, the RESTful API and so on, is to be found over there. That's why I think it's important that I do again a quick walkthrough over the repositories. We'll do then, most importantly, we'll talk about the booting, and as part of the booting, it's important that you understand the Bootstrap service, for which, by the way, there is also a repository. I didn't list it on the slides, as you will see it in a minute, but it is there. So meaning you could even set it up yourself on a private server if you would want to do so. But it's interesting to see what it is, how it can be used, because it will help you to get started quite quickly. Then we'll go over the boot options. Well, the documented boot options, because you have much more boot options than the ones that we have been listing so far. And I will go over all the boot options, and then we'll try some of them. We will do again the interacting with ZeroOS through Python. But this time I will go over a little bit in more detail over the commands, the basic commands, and we will explain what ZeroCore is, because we didn't really explain what ZeroCore was. I remember in the first session I was like talking about the init system and the init process. I have a correct definition now in a slide, making sure you understand that quite well. And then again, I talked about setting up a JumpScale 9 Docker container. I already included the instructions on how to do that last time. Again, I included that slide here. And I think it's important that you know that, because it's for all the next sessions quite important that you have a Docker container running with JumpScale 9 pre-installed. Even today, I plan to use it just to show you how to deploy a ZeroOS at OVH. Just to show you how much easier it can be if you have JumpScale 9 available, because JumpScale 9 will do some heavy, weightlifting, or how do they call that, for you, instead of you having to write much more code. Good. So this is the schedule. So we had the first session on Tuesday. We already covered in that first session a demo where I showed you VirtualBox, and that I use VirtualBox to basically boot a ZeroOS instance, and I used Python to interact with it. I can do that again. I'll show you. This time we do that also, but we'll go a little bit more in detail. Next week, I think for some of you, that's where it becomes more and more exciting, I think, because there you really start to deploy actual workloads on a single ZeroOS node. We will then introduce what we call the FLISTs. And FLISTs are basically a concept based on a fuse layer on top of the ZeroOS file system. That is quite important for containers, as you will see. It's a quite interesting topic. It's what is being implemented in the ZeroFS repository, which is also available for you already today if you're curious to look into and even start playing with it. Next Thursday, then it's really becoming really interesting. And I'm planning to prepare a very nice slide also for that, to make it very clear how it works, because then we start taking more than just one node and combine them basically in a cluster. And then we will introduce the concept of the orchestrator. It's a RESTful API server that allows you to talk to the cluster as it was one computer, allowing you to basically deploy any workload into the cluster you want, not being aware necessarily of how many nodes are being involved and stuff like that. It's really like an abstraction layer on top of a ZeroOS cluster. And that's where things really start to become interesting, because then we will, in the next session on July the 4th, no, I will already tell you, the sessions of July the 4th and the 6th, most probably I will postpone with 1 week, not because we are not ready, we are certainly ready to do these sessions, but simply because I will be taking off that week. But anyway, the next session then is really about working with virtual machines and with virtual disks. And you need a virtual disk, you need a virtual boot disk for booting a virtual machine. And then we will basically show you how we will, first of all, deploy the block storage layer on top of a ZeroOS cluster. And the block storage layer basically is just an example of a workload that you could deploy in a ZeroOS cluster for supporting, in this case, virtual machines. And that's all what you will see in the sessions of July 4th, and which is then the basis, of course, of what we will do in the session of July 6th, which is quite challenging, because there we will for the first time show you a ported version of OpenV Cloud on top of ZeroOS, which is quite interesting, because for those that know OpenV Cloud, they also know that in OpenV Cloud we have concepts like a cloud space or a virtual data center. We have concepts, well, they are based on RouterOS. Clearly, the way we are implementing the same concepts like cloud space or, well, a virtual data center is not anymore based on the RouterOS, but will be based on new concepts that we introduce through the orchestrator APIs, as you will see and as I will explain. And then for some it's not new, but it's certainly new from the perspective of ZeroOS. We will show you how you can then use at your service, both from the command line, from the RESTful APIs, from the perspective of sending blueprints, in order to get things done, basically on ZeroOS, and more specifically on OpenV Cloud as it runs on ZeroOS. And the last session is then about creating your own at your service templates, which is basically, remember, at your service is about, well, making interactions with at the end, the backend, with the workload, with the system, through the RESTful APIs, making it easy through the concept of blueprints, where you really send human readable documents to at your service that then will be interpreted by at your service, not just to deploy and do the actual provisioning of the workload that you are requesting to get deployed, but more importantly, basically, allows you to have a system that will take care of the full life cycle of whatever you want to deploy. Now, in order to make that happen, you need to understand what is being covered in the last session. You need, of course, at your service templates that do not only take care of the provisioning, but also take care of the auto-scaling and the auto-healing, mainly, basically, monitoring the workloads after they have been provisioned and making sure that when things go wrong, that these templates are ready to take actions. And in order to take actions, you need to implement some code, Python code, into these templates. And that's where you typically will leverage JumpScale. And remember, JumpScale, that's one of the things that you will install as part of, well, of this session, or, well, at least as a preparation for the next session. And by the way, I remember you to tell you, you can always contact me if you have questions, if you have issues. I just had to talk with Arne, and he gave the very correct feedback that many people, of course, use Windows, which is quite normal. And for instance, for the Python client, for instance, I think it's normal that we support you also going forward in using the Python client on Windows. The same thing goes if you want to deploy, for instance, the Docker container that we were talking about. You will want to deploy it on your Windows machine. Well, most probably leveraging the Linux subsystem. But when you start deploying, for instance, a ZeroOS well, it should be, why not? It should be possible with Hyper-V too. All these scenarios should be supported going forward, and that's certainly something that I take with me, whatever feedback you give me there. Now, again, let's do GitHub repository walkthrough. The very first one is basically about the kernel. So it's having a very difficult name, initramfs. For some of you, this is certainly not Chinese. Initramfs is a very well-known thing. It's not something we invented or something. It's our implementation, yeah, where we basically create the kernel, yeah, and basically have a kernel that is really very, very lightweight, that is only containing the things you need to support what ZeroOS is actually about, basically securely hosting containerized applications and indeed virtual machines in clustered deployments of ZeroOS. And initramfs has as main task to make sure that the zero core, and that's why I need to explain, of course, in one of my next slides, gets started. So it's basically the bootstrap thing that starts, and then the kernel, and then zero core needs to start. And zero core, as you will see, is then discussed and is then implemented in this zero core repository. And all the documentation that we cover today is basically in that repository, because everything we do during the first session and this second session is about booting a ZeroOS on, well, a virtual machine or a physical machine, and it's about basically deploying the kernel and making sure this zero core thing gets installed. This zero core thing, as you will see later in the session, is this thing that receives the commands through Redis. Of course, you will not talk to Redis directly, you will talk through Python clients, for instance, or Go clients, in order to get things done from Zero OS. Yeah? Now, all that is nicely implemented in the Zero Core repository. The Zero FS, that's basically what we will need for the session of next Tuesday. That's indeed this Fuse file system on top of Zero OS that enables you to deploy containers. Now, the Fuse file system, or Zero FS, allows you to deploy other stuff too, based on the Fuse file system, but our main goal with it is indeed to enable deployment of containers and running containers. That's this repository all about. The Zero Disk is the workload that you can then deploy, because this is about a bunch of containers. So it requires on each Zero OS this Zero FS thing, which is always there. And the Zero Disk is about the containers that that you typically deploy in a cluster in order to have block storage available, which you then need, for instance, to create virtual machines. Now, actual deployment of a virtual machine is done typically through the orchestrator, through the RESTful APIs and the Python client, or other clients we will support, like the Go client we already have, to for instance, deploy a virtual machine on top of a cluster. Now, as you will have noticed, well, at least some of you will have noticed that in the documentation, I need to update that you will find in Zero Core, there is a section about virtual machines, as if you could indeed also deploy a virtual machine directly on top of Zero Core. Now, physically, it's technically and theoretically, it's certainly possible, but that's certainly not what we want to show you, and that's certainly not what we want you to do. We really urge you to wait until we have explained basically the orchestrator stuff, until you have deployed your own first cluster, and then we will show you how to deploy a virtual machine based on the RESTful API exposed by the Zero orchestrator, or the orchestrator, I must say. Good. So that's the orchestrator. And then the other repository is the Zero Hub. And the Zero Hub is basically the hub where, first of all, we of GigTech, we make available all official what we call FLISTs, or basically, templates, also virtual disk templates, but more importantly, all container templates basically. And a container is basically always based on what we will explain in the next session, a FLIST, and all these FLISTs are available. I'm working with third parties. For instance, I'm not going to share too much information about that, but we are working with a third party that we have a good relationship with to create, for instance, a container that will provide you, you will get excited when you see it, will provide you a cloud desktop. So a fully functioning cloud desktop that nicely integrates with itsU.online. So basically a cloud desktop allowing you to go through any browser and basically log in with your itsU.online identity and get a cloud desktop that even includes things like an Office suite to create documents and sheets and stuff like that, all through a cloud desktop. Now, for this cloud desktop, and that's the exciting part of it, we will make sure that we have a FLIST. So what this means is that we will run your cloud desktop in a private container in a cluster. So that is one of the more exciting things that will be supported through all what we will be showing you. And the hub is basically then the place where we will make available these FLISTs. And it's of course also the place where you are being invited to share your work for others to use. Okay, so this is not new. I already covered that last week, but I think it's important that you understand that because that's where you will be navigating for help, for support, for README documentation and stuff like that. Okay. The recording is on, my dear friend. Yeah. Now let's talk a little bit more about the ZeroOS Bootstrap service. And before I do so, if you go to the repositories, remember ZeroOS, so github.com ZeroOS. There you see the main repositories. There is one repository I did not really discuss. It's the home repository. It doesn't contain any code or any implementation, but it's typically containing all the, let's say, documentation that doesn't belong in the other repositories. So it's like the common documentation. So going forward, much of the documentation will become available here. But what is also important is that there you will find things like the release schedule, which I discussed last time. And I think it's certainly interesting for you to check on that so that you understand where you are. Basically, important to know, we are about to release next week the release file. Good, that's good for you to know. Well, next week. It's planned for next week, yes. We are close to make that all available. Now, what I wanted to show you is that there is indeed, these are the main repositories, but as you will see, there are other repositories too if you go to ZeroOS, and one of them is, for instance, where is it? I'm looking for the hub. Yeah, no, not the hub, but the Bootstrap server, Zero Bootstrap. Where is it? Probably. What is always possible is that they exclude me. So Zero Bootstrap. Let me show you. Voila, that's the one. Voila. So this one was not listed in my slide deck, and that's the one I'm about to discuss now. The ZeroOS Bootstrap service. And by the way, what you always see, just for you, we try to keep it clean, and it's work that will never end. That's basically my job in the company, is making sure that the documentation stays clean and consistent. But what you always see in each repository is that we always have a README file, and the README file will certainly contain documentation, which is typically written by the developers themselves. It's really concise documentation. It's typically the type of documentation that developers love, like only the stuff that they need to know, not too much prosa, just straightforward the information they need. While what I always do, I will always create a folder docs in each repository, and also there you will find a README, and you will find, no, in this case there is not much, you'll find more documentation. So you see, it's a little bit more prosa for the people that are not into development themselves that much. And need some more guidance. This always gives more information. Now, in this case, you will see this is quite okay. It's even better than what I already have in my prosa. But the reason why I'll show you, so the ZeroOS Bootstrap service is basically a service, and I'll show you. It's basically a service that that is available on bootstrap.git.tech, and it is something that is also open source, available for you to check how it works, and you could even deploy it yourself if you want to do so. It's basically containing two things. It is basically behind the Bootstrap service, just for your information, there is an auto builder. There is a system that that is constantly building the kernels. Yeah. Each time when we do a commit, each time when we change something to the code, we will auto build a new kernel. As you know, building a kernel takes easily an hour on a fast machine. So that is something that we do automated, so automated building, auto build basically. And then we make sure that through the Bootstrap service, you then see for each release, well, a release is a branch. For each branch, you see the latest build. Now, for instance, this one is probably the most important one, the FE file. FE is the kernel, that's the actual kernel. And the 0S master is basically the most recent version of the kernel as it got built in the master branch. And the master branch, remember that, is always the branch. It's not always a stable branch, of course, but it's always the branch where we are working on. Yeah? In this case, there's not much to see, but in the other ones, you will see that if I go to 0S, let me do that. Also here, you will see that we have like this. Let's go, for instance, to the orchestrator. That's the one where they're very busy. In the orchestrator, you will see all branches and all tags. See, it's for you. So that's important to know. So we are working currently. The stable one is this one. Not stable. It's the one that is being tested, that is being released, and the next one will be 110 alpha 5. So that's how it works. And the master one is basically the one after the next one that will get released. So remember that it's important, because as part of booting, you will always want to download the kernel or the ISO file or the USB files or whatever, and then you will always need to specify the branch. Now remember already today, you could specify the full branch name, that is 0S master, but that's only for backwards compatibility that we still support that. In reality, as you will see, you can just specify master. You should typically never specify 0-os-master. You can just specify master and FE. What I'm talking about is the following. Let me show you. When I do in the URL the following, bootstrap-gig.tech, I can specify things like ISO. And by specifying ISO, I say, just provide me an ISO image. And the next thing then you specify is the branch. You say master. Yeah? And then the next thing that you specify is zero tier. We haven't been discussing zero tier a lot. But zero tier, it's not something we created, but something we fall in love with. We use it, we leverage a lot. It's certainly something you will want to check out yourself if you didn't do it yet. You will have to, because we use it extensively in your environment. It's basically in the cloud. It's in the cloud switch that basically nicely connects multiple containers, virtual machines, cloud spaces even, going forward through a private network in a very secure way that we nicely support in our environment. What you will typically do there is you will go there, and it's free to get started with. You create your own zero-tier network. As you will see in my case, I've created a few networks. I have 2 networks, and like this one I created yesterday, and you just click create. It's quite simple. Click create and you get a network, and in that network you get then an ID. See, this is the ID. It's important, never forget that, because that was the mistake I made in the beginning, is that whenever you create a network, one of the very first next steps is to make sure that you specify that an auto assignment should take place in a specific range. If you do not do that, nothing will happen, it will not work. In my case, every join request, and I'll show you what it is, a join request. Every join request into this network will then end up with an IP address that, for instance, the container, or in our case, the 0S node will get from that range. And that's what you then typically see here below. I didn't use it yet. You can then see who is requesting. You need to authorize it and so on. That's, by the way, what I see, for instance, in this one, which is used extensively by myself. You'll see here, you see everything, and typically I only want to see the online ones, and then you see basically all my machines that are online. I have a machine running in at OVH. I have a machine running in Docker. I have a machine running in Dubai. I have some friends in Dubai and in Cairo, and they all have machines that are nicely connected into my zero-tier network. I have my Mac, which is directly connected by, and you certainly also have that for Windows. So just install this add-in. So in Mac you can install this thing, so that automatically your host system is also nicely connected into this IP. So you need that. Now, going back to my point here, you need to then to specify this ID. So you typically copy this ID, copy. And let's take, for instance, the other one for a demo. So you copy, because I don't use it yet. Copy this ID, like this, copy. And here you then specify the ID. Now, by doing so, I'm basically requesting a kernel, not just a kernel because I'll get an ISO, I am requesting an ISO, so meaning including a bootloader, yeah, and it will make sure that when you boot it, that's very important to realize that if you boot it, when it comes up, that it will automatically talk to zero-tier and will automatically request to get joined into that network, and then somebody needs to do it physically. Now, just for information, and in some of the example codes we do that, for each of your networks you can also create, well, you see it in account, you can create, you will see it, API access tokens, and clearly zero-tier of course has also a RESTful API, and this RESTful API requires that you then have, of course, this access code. Okay, you should not have seen this one because this is mine, but with this access code, you can then basically go to my network through code and automate it, and basically grant access not manually, but by doing it through code. And that's what we do, for instance, through the orchestrator. The orchestrator will certainly do that for you. Now, just remember that when I do this, so let's do this. The download starts now, and as a result, I get here it is. I get a download of an ISO file that I can then use to boot. Now, yesterday I had a chat with Herbert from Austria, who was using this in VMware, right? And he noticed that his machine, when it rebooted, always got another IP address. To be honest, Herbert, I didn't have the time yet to check the real details how it works, but that's quite normal. And you gave the answer yourself. Remember, ZeroOS is a stateless operating system. So each time when you boot this thing, there is no state. So it doesn't remember nothing at all. It doesn't remember its IP address. It doesn't remember nothing at all. It only knows the 080 network ID, and it will request an IP address. And then maybe it gets the same IP address, or maybe it gets another one. See? So in that way, it's by design, it's like what you could expect. So it's perfectly normal that you got another IP address. To be honest, I need to check that. I was rather expecting that zero-tier itself would give you the same when some conditions are met. So probably there are conditions on which you get the same, and in other conditions under which you get another IP address, right?
No, I've read the documentation of zero-tier. It's by design to generate the new ID, not to get any conflict. So it must generate the complete new ID.
Okay.
When you install it.
Yeah. Good. Excellent. And you said you were writing documentation?
Reading.
Reading. Oh,
reading.
I always love people that say me that they are writing documentation. You can always send it to me, and I will steal it with love and put it online. Okay, good. So that's important for you to know. Now, the other thing, so I just gave a demo on downloading an ISO file. But remember that you can also download other stuff. As you can see here, what I did is this. See, as documented, generate a bootable RC boot blah 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 of FE. But you can also do an USB one, and there is documentation in booting. I'll come back to that one later. You could also just specify a kernel. Well, specific name of a kernel, nothing specific. And this one is interesting because this allows you to basically download the bootloader, the IPXE bootloader script, which is quite interesting, as I will show you in one of my code examples. For instance, if you want to deploy ZeroOS on Packet.net or, for instance, on OVH, because then you need basically a link to the IPXE script. I can show you. If you just take, well, the same thing here. You could go to, where is it? My boots, the same one here. So just do IP like this, and then you get the script. It's quite simple. It's a bootloader that then says, and the reason for you, if you're new to the concept of the bootloader, an FE file is just the kernel. But if you use a kernel and put it somewhere, it will not do any, well, it will boot, that's it. But you need a bootloader in order to pass basically arguments. And this bootloader script is a very straightforward bootloader script, will get passed, or will basically pass the zero-tier ID to the FE, to the kernel. And as you can check in how it is being implemented, we accept as the first parameter in the kernel the zero-tier network, and then this kernel will know what to do. Basically, request a join into the network. There are other things you can pass to, as documented, for those that want to do more sophisticated things. Like there is, for instance, a debug option that you might want to use. And the debug option allows you, for instance, to SSH into a ZeroOS thing, in the ZeroOS instance, which of course is not there by design. Good. Voila. Furthermore, what you will see is these are each time the last builds, and down the line you see then all the builds. So all the builds. And that's what you see, the number here, it's the name of the commit that is behind it. Good. Voilà, this is important for you because you will be using it quite often. So this is this slide. And here I repeat again the way you would do it from command line prompt with curl commands, download it, and so on. Quite straightforward. Yeah. Then the boot options. The boot options, there are many. Well, there are many more than what we already document. The documented ones are nicely summed up here with working links. To be honest, myself basically, I've been focusing on the VirtualBox one. I've been playing with Packet.net. Yesterday I've been working with OVH, I will show you. My friend here next to me, Donato, has been working with the PXE boot server. He also got to work that. We are still in the process of updating not the boot server, but the KMU one, this one. We are still in the process of updating a little bit of documentation, but basically it works. And I think for especially people working with Linux, that will be their most preferred way of doing it. Yeah. But clearly, some of you will want to do a USB or a CD, or put the ISO on a CD like somebody did. That's all very possible too. Good.
I think on that list, VMware should be added. VMware should be added.
VMware should be added. Yeah. Yeah. Who is saying that?
Arnie.
Yeah.
And if
Yeah.
I also did it on VMware. VMware Workstation. It's very, very fine tool.
Yeah. So, but you were asking for VMware, right? You want to?
Yeah.
Yeah.
It's working on VMware, and
Yeah.
with the ID, it's just by design. It's not related to the hypervisor.
No. No, exactly. But then again, we should make sure it's documented, even if it's something that's quite straightforward to document. But at least it shows that we support it and that we test it, that we go, because it should be part of the testing, integration testing, continuous testing. That's basically the point. Good. The other time I showed VirtualBox. I could do it again. Not sure whether it is that very useful. Well, I will not. It's done in the recording of the last session, so go and check that one yourself. What I want to do now is not clean up my hard disk, but I clearly have a need to do so. Is show you how to do it from JumpScale, and it's maybe 2 steps ahead on what you would expect me doing, because, well, JumpScale, what is JumpScale? I have been explaining much about JumpScale. Most of you on the call I know very well what JumpScale is, but then again, still, I should introduce it properly in the sessions too. The fact is that JumpScale is basically the work we have been doing here over the last 10 to 15 years. It's basically a collection of libraries, APIs, to make the life for basically Python programmers simpler, easier when you want to work in a data center. So it's about automating whatever you typically need to automate in a data center, the provisioning work, the self-healing work, everything. We try to make it simple through a set of comprehensive set of APIs, modules that we nicely integrate under JumpScale to get things done. And one of them is the client for OVH here that is nicely integrated, and where we have, most importantly, this thing here that allows us to boot a server in that environment. So what you see here, the client allows us to boot a ZeroS. So it's one line, one single line that allows us to do that. In my documentation, you'll also find a plain Python example, basically code that you could run from any Python interpreter that would do basically the same thing, but with lots more of code. Let me show you. So this is a machine. This is a machine where I'm logged in. So I'm logged in basically. Okay. Not sure why it is slow. Should have tested it. Yeah. So I'm logged in on a JumpScale 9 Docker container. So just so this is my root machine, and I'm logged in on this machine, and this is basically a Docker container running on my Mac with JumpScale 9 nicely installed. Remember, the last slide in my presentation shows you again a link to the documentation how to do that, and also, of course, includes the basic commands I use to do actually that. Now, once you have that, you can basically interact with JumpScale 9. JumpScale 9 is like the IPython 3 shell, but then including everything you need to talk to the Python environment. Now, I'm a lousy programmer. Well, I'm not even a programmer. I try sometimes to be a programmer, but a long time ago I decided that I'm not designed to be a programmer. So, but then again, I still love to try. And here I will show you how easy it is, based on good documentation. Now, once again, realize that we need, of course, to have a machine. We need to boot the machine first, and that's what we will actually do. We will this time boot the machine through code. The other time we booted the machine through to manual interaction with VirtualBox. This time we will be using code. We'll do this in 2 examples. This is the first example for OVH, and the second example will be about using basically the command line to do QEMU. Now, before I actually start here, let me show you in the documentation what you actually need to do. The first thing is you need to go to this, well, you need to go to, in this case, to OVH. You need an account over there. We clearly have an account. I'm not going to share with you the password, but I clearly have an account over there. So what I typically need to do to get started is, once you have an account, you typically start by creating an API key. And this time I'm going to create an API key that's only valid for 1 hour, and I'm going to specify a script, doesn't matter too much, call it the EAP demo script. For basically booting Zero OS on OVH, on an OVH server, right? 1 hour, you specify that all the APIs you need, like this. I need a put, like this. Yeah, and I need a get, no, a post, like this. And I don't think I need, but anyway, a delete, but you could, if you want to, you could do it. Create the keys. Voila. This is then the keys, and that's what you need in the code. So going back to the code here, in the documentation or in my slides, what you need to specify now is this. So you need to go to, well, let's do it like this. Let's make it simple. I copy the app key, go with here, app key equals like this, and the app key is then nicely application key. It's quite cumbersome to do, but you get the point, right? Then the second one is done. We need the app secret, copy app secret equals chuck chuck. You could do it yourself if you wanted to, because it's valid. It's valid for 1 hour. Don't do it, because you will be ruining my servers. It's quite powerful, but also quite dangerous way of doing now. Let me not make any mistake. And then the last one, consumer key, the consumer key, like this, equals, right? Well, oh, what was it? An O?
Yeah, O.
It's an O, not a zero, right? There we go. And then, well, it's straightforward. Then you basically do what I documented. You basically then go to the client objects, and the client, all the clients in JumpScale are available under j.clients. In this case, I need the OVH client that we have here. So it's our own OVH client. And there you see them, it's installing it. OVH client dot get. Well, in this case, I need to do get. Yeah, it's annoying the very first time you do that. So j.clients, let me copy it. Right, there you go. Okay, it succeeded. And the very first thing that you will want to do is list the servers we have over there. In this case, we will list the servers. And you could check this variable like this, copy, all works. Then you see all the servers we have. And I'm going to use this one. That's the one I used yesterday, so I guess I can reuse it now. If not, somebody will hit me. So I have a small code here that allows me to select. I say, let's use the second one. Voila, nice code. And then this one, remember that you need to link to the, so I need to be careful now because I didn't specify these things yet. So a link to the script, so branch in this case will be master again, right? Now let me think, I should really, don't make any mistake. Yeah, this master is really the master of, yeah, I need the master. And the network, of course, is the ID of the zero tier. So this time he will do everything for us, and we don't need to download something. The whole script will do the download for us. So in this case, the zero tier network, we could take the other one again. Go to networks, take this one, copy, go back to my code, and put it here, right? And then finally we get the PXE script. It's basically returning only it's concatenating the URL to do it. And then actually, the only comment that is really, really important, that is basically then booting my machine on the other end. So it's actually happening now. And while this is happening, there is this link, of course, that allows me to check on OVH how things are going. I need to log in, of course. Yes, log in, and over there, I'll then see my servers. I took this one, and it's being booted now. Yeah. While this is happening, also as documented, you can always check on the task and never this thing here should work. This thing should return when
task ID should be number.
Should be, it's not correct. I need to update that in documentation. Yeah. Anyway, I'm pretty sure it worked already. So because I should be able to get the server ID. Yeah. In the documentation, I have more extra code that also returns. Let me show you. If you go to the documentation, 0OS, remember, 0 core, and you go to docs, you go to booting, no, to interacting, or in this case, booting, it's still booting. You go to OVH, and there you see then the code that I used. Well, this code is not, well, the reason that you don't see it here is because this code is waiting to get approved by you need to go to docs update, that's where it is, exactly. And here you see my code that I was using. And this one, I did not include it. What I typically will show you is that you can also fetch the IP address, the ZD IP address from it. That's here, that's what I wanted to show you. So I did not include that in documentation. So what I can do with this one, I can go to this network, and now the IP pub, did I get it? Yeah. IP pub. So if you do IP pub, let me check it just to be sure. Yeah, so that's really the IP address you got from OVH. And what we need to do now, of course, is based on this public IP address and indeed the zero-tier network, we want to get the IP address. And this will not work. I will explain you why. because we didn't accept it yet. So if you go here, see, I should now manually accept it. So I knew she should now authorize this thing and say, okay, accept it. And while this is happening, so you will see that the IP address will be assigned. Should not take too long. There it is. It got an IP address. And as a result of that, this should work, or should have worked. Maybe I should do my call again here. Not sure. But it should have worked. I don't know what went wrong, to be honest, right now. But you get the point. So the IP address this should have returned me the member information of this new thing. But I don't know why it doesn't work. Forbidden for URL.
You need to grant something for.
Yeah, but wait, it's 5. Ah, okay.
You need to access something.
Yeah. 5A. So basically, and this client is not. Yeah. So what I need to do, I think Mohammed is right.
To accept.
Yeah, of course, very good. It's always good to make mistakes. So what I will do, I'll do Ctrl Z, and then do the VG, FG. And what we need to do now is we need to do zero tier, CLI, join, and we take then also this IP address. Joined, and then we still need to check here because he will request C, so we accept it, and you can label it here just for your convenience. I will say here that's OVH, and this is my in this case it's my Docker container. I call it GS9, right? This one will get an IP address soon too, and that should allow me. Let's wait, go back, of course, to foregrounds here. Let me just be sure. Ah, I didn't accept, didn't I? Strange. Refresh. Okay, so it got an IP address, not sure now, member, yeah, so still I'm not sure whether I'm doing something wrong. It's the correct IP, forbidden for URL.
Can you try this URL?
Yeah, no, I'm thinking what could be the reason. Somebody that is smarter than me on the call that might understand what I'm doing wrong here? Nobody? Go a bit. Yeah, no.
Start from. Go on.
Lower.
Step by step.
Is that the IP pub? Yeah. So it's running. Yeah. Like this space.
Go on. So it's getting network member from IPPub. Okay.
And the IPPub did it because that's maybe
It's populated, I guess.
so. If you go to the here, just to be sure, this is it's running zero tier, and you see it nicely got, so it clearly worked. So well, it worked. I mean. And this is the IP address we got also back. So that's this this IP pub is indeed this IP address. We can clearly see that it got joined into the correct network. The only thing that I can think of is the clients. Let me check what I did. So the clients, yeah. Let's do this again. And then,
Did you run this step, which is the PXE script? Did you run it?
which one?
Did you run it?
Yeah, we did that. We did that. We did that.
Okay.
And we should not do this again. I could do this again. Should not be an issue. I could even, yeah, no, do it again. Control-C. Yeah, then again, show me the IP address like this, and then in the documentation, well, ZT is also correct. ZT, okay. That's maybe the reason I had to do the ZT again. That might be the possible explanation. No, okay. So I don't know. I need to find out as a follow-up. It's a pity because that would then allow me to show you nicely this IP address that I got from the zero tier. Good. What I'd love to do now, can we do it on your machine?
Yeah.
We want to show you the QEMU example. And anyhow, when we have the QEMU example, then we can do through Python interact with it. Huh? So let us show it on another machine. So I'll stop sharing my screen and you share your screen.
Yeah, but I need the cable.
You don't need the cable, huh? You just share.
Sure.
You're in Zoom, huh?
Oh yeah, for put it there and maybe
Yeah.
it's, but yeah, it's okay.
So,
So now we will go through the Zoom here. No?
yeah.
Okay.
Well, yeah, and then share screen. Yeah. Yeah. Go ahead and you share the screen.
Okay.
Well, wait that we see your screen.
I already have.
Do you guys see the screen now? It should be shared now, huh?
Yes.
Yeah, I can see it.
Yeah, it's okay.
Excellent, good.
Okay.
How can I put it there?
No. I already have the machine loaded, but yeah, we can do it from the beginning.
Okay, and I give the word to Donato. Huh? That's easy for me.
Okay. We'll see. Okay. Order this. Well. Yeah. First of all, like you see in my documentation,
This is new documentation.
it's
that's
new.
it.
It's not. It's
Yeah.
not uploaded yet. So yeah, first of all, you need to check if your computer have hardware virtualization with this command. So just go to the command line and copy that. Enter. If you see that some of the words like UFMX or SFUM is in red or just appear, then that means that your computer supports virtualization. So you can continue with that. Well, doing that, yeah, you need to install QEMU. Here, when we upload this, you have all the command that you need for install it, if you haven't yet. And after that, we can start. So first of all, you need to check the default. The bridge is on. So yeah, check. Maybe put it bigger, or is okay?
Is it good?
Yeah, like that.
Perfect.
Yeah. Then I have to change anyway. So okay, as you can see here, the bridge is active. But if this is not your case, you need to use this command for a start. Yeah, and then you can see here that it's going to be active.
Maybe you can show the configuration of the bridge, or no?
Yeah. Also, this is important, and I had some issues with that before. You need to go to the root. And then you need to go here to yeah, David touch. Yes. Yeah. etc camel, and it's a bit slow. Yeah. Come. Yeah. You need to allow the second one, huh? Okay. This one. Okay. Well, then the command line one is not working at all yet, so we use the GUI. So just go command line and open the virtual manager. I already have opened it, so
create a new one maybe.
yeah, create a new one. I'm gonna stop this one or just delete. Yeah, okay, just stop it. First off, yes. Then, so for create a new virtual machine is really easy. Eh? Just press the first button on the top menu, and then keep the first option selected and click forward. Then you need to first download the ISO image, like if explained before, and then through browse you can select your image. Browse welcome. In my case, I have on the home folder. Just open it and forward. Normally we use here you need to specify the RAM memory. So we normally use this memory and click forward. Then specify the storage. Yeah, this is too much. You can play with that a bit. This for the disk. And forward and just choose the name. 0S and finish. Okay, we already have one. So 0S camera, whatever. Click finish. What cannot contain? Yeah, okay. Yes. So like that. Then we need to wait till the machine is get the kernel and was installed. It's a bit slower. You can see.
And you have an also zero-tier network, another one. Okay.
Yeah. When this is finished, then we check here that it's going to appear a new machine. We need to allow it, and then we can start with the command line with Python example. So it's gonna come back here.
And what command line would you look? You maybe should already prepare with that with
yeah.
With
I already had it. Yes. Okay. Yeah.
So maybe good that you show what you're about to do.
Yeah, I'm just in JavaScript 9, like if show it before.
Yeah, so this could be done perfectly from Python, IPython. So
Yeah.
you don't really need the jump scale
Yeah,
line.
you don't
container.
really need it, but it's the same.
It's the same.
It's
It's the same.
So I'm going to use that. That's IPython. That's IPython. Well, this is starting. We are going to continue configuring here. Just this we can. That's the only thing we can do now. It's just from. Well, and then the IP that we haven't yet.
No.
Yeah.
In the meantime, can you show my slides maybe on the browser?
We share it. Yes, we share it on Telegram.
Well, let's share it with you. Wait.
Well, yeah, this is almost okay.
So now you're allowed from.
Now you're okay. Then let's wait for
Yeah.
that. Just
Okay.
finish.
So now you see the connectivity is okay. Oops.
You boot again.
Yeah, I did something wrong.
Why did you boot? By mistake.
Come on. Okay. Shit. Okay. Let me
You
check.
booted by accident.
Yeah.
And I need to reboot again all over.
The problem is, I can. It's the only way that I can get the mouse again.
You have to.
So yeah, well, I have to boot it again. But we boot. Let's close it, and then we can, or just I can restart. Yeah, but yeah, it's gonna be the same. So
Yeah, the running one is
the running one is
the one that
the wrong one.
yeah. Can you?
Yes. Shut down. Oh.
Yeah, of course we will need to go through everything.
Yeah, again, it's gonna take at least a couple of minutes.
Is it?
Okay.
Okay.
Just share your.
Yeah, let me take the screen back. Try to get it right. So
Yeah.
sharing the red button there. Click stop share. Yeah. Okay.
Ani is asking for Python 3.3.
5 in my case. Yes.
Okay, let me again share my screen now. There we go. So, this is the booting 0S on QEMU. As you can see, things can go wrong. But once again, I invite you to try it yourself. It should work. We are there to support you. I can guarantee you that I will, as a follow-up, make sure that I understand exactly what went wrong in my last piece of the demo and come back to you on it in Telegram. But it should not block you in trying it yourself. Now, talking about zero core, we talk a lot about zero core, and it might confuse you a little bit because sometimes people here internally talk about core zero, and then sometimes people talk about core X. It's all very confusing. Now, ZeroOS is clearly the open source operating system we provide to boot lightweight, very securely, and enable you to run workloads in virtual machines or containers. And the core component, one of the most important components in ZeroOS is Zero Core. It used to be called internally Core Zero, and people still talk about Core Zero here in development. And somewhere left and right, you will still see the word Core Zero. But Zero Core is the official name, and it's basically our replacement of Systemd. So Systemd is, I think, well known by all of you. It's in all popular Linux distributions, the init system that is currently included in all these general purpose operating systems. Systemd is very general purpose. It's including a lot of things that we don't need. So we created our own version of Systemd, which we call Zero Core, and it's actually bootstrapping the user space, and most importantly, of course, manage all processes that come after it subsequently. Now, interacting with Zero Core, and that's the main functionality of this thing, the interacting of Zero Core is through Redis. And Redis, you can look it up, that's what we use. It's an on-disk key value store that we use as a message queue. A message queue that listens on a specific port, and basically that's the only way you can interact with the ZeroOS operating system through Zero Core, more specifically by sending messages, commands, as I'll explain you in a minute, over the Redis port that you specified in the configuration when you did build indeed the kernel. We don't have any session yet on how to build a kernel and how to do the configuration and, for instance, set the defaults, for instance, when we talk about Redis. It's all documented too in the very first repository I named, but for now it's certainly not important. Now, managing indeed ZeroOS through the Redis that is exposed by Zero Core is quite simple. The idea is that you send comments, and the comments are always in the structure that you see to the left. You specify a command ID, a command. Depending on the command you use, you typically can send a lot of arguments, and then there are all kinds of other parameters which are quite straightforward. One of the last one is the log levels. That's certainly also one of the things for which you will for sure later organize a specific session explaining how to monitor a ZeroOS and how you can control the logging of the system. It includes a quite sophisticated logging mechanism that allows you to control in the way you want. And also that part is already documented, but for now I don't think it's quite important to show you that. But we'll certainly also organize a session on that one too. More important now is that for a basic ZeroOS, we come with a set of basic commands, and here you see a full overview of the sets. We have commands which are, of course, related to core. I will click on it in a minute. Things related to zero tier, things related to the file system, things related to disk and bridge and BetterFS. In the last session, we showed you, for instance, how we could format the disks through the BetterFS command set and so on. We also used the core commands. Let me click on that. And then you go to the documentation. And we showed you in the last demo, maybe you could prepare that for you with your Python. Yeah, so when we switch back to your screen, that we ping your system in Python and that you show your example in Python. You prepared the Python script, right?
Yeah, but
yeah.
This, yeah.
Let's wait for that. Now, in the meantime, here you see that, so for instance, the ping is there, and each of these commands is nicely documented. The ping is quite straightforward, but there's, of course, one that you will use quite often is the core system, core.system, which allows you to send basically any commands like even ls, -l root, for instance, will allow you to basically do this. You could also do like things like apt-get update, apt-get install, all these things that you typically would do with a Linux operating system can be done through the system one, and kill and so on. That's quite straightforward. Other examples in the comments, if you have a look to comments, we have, of course, things like disk management. For disk management, you will typically then create all the devices. Then you will basically create a partition table. You will basically do the mounting and things like that. It's all very nice documented. I think the last time I was showing in the context of BetterFS examples here, like you could create one. And remember, for creating and remember that I showed this example the last time, where you could then specify devices, and then you could then specify like how you want to format these devices. And I did use RAID 0 the other time. By the way, the example I used the other time basically worked perfectly. I just had to specify one of the two devices and not the devices as a parameter. And it's as is in the documentation and also in the updated slides. I'll give back the screen to you, so that you can show something from your machine in interacting with your environment. Yeah.
Yves,
Yeah.
can I ask one question?
Yeah. Go ahead.
When I send some comments and configure something, where is stored this configuration?
Well, sorry, which configuration do you mean?
If you do something with the disk, if you make a disk array and format the disk, where's this information stored?
Where is this information stored? Yeah, I see what you mean. From a stateless perspective, you mean?
Yeah, from a stateless perspective, yes. Because when it's in the memory, it's lost.
Yeah, you make a good point. To be honest, I don't know. We'll come back to that one too. Where is it stored? So basically the question is, if you reboot the system, what about the disks? What about whatever you have been created in format? That's what you want to know, right?
Yeah.
Yeah, good point.
Maybe we can try it now. We'll just create a
disk and then
file
reboot
system
it.
and reboot it.
Is that what you were going to do in your example? Storage pool? Yeah, you do storage pool.
Okay.
We can do it, but let me check first that I have. Yes, we can do it.
We create one and just put a file on it, and
we can do it. I think never try in Chem, but
no, let's try it.
exciting.
No strings attached. We are not faking here. Things go wrong, and we'll get to solve everything.
Okay. I'll continue with the last task. We already have a few minutes ago the machine working. So if we come back to Cloutier, we need to allow this to the network, and we are going to have the IP address of the virtual machine on Chem. So we just copy that and come back to the terminal where the IPython client is. So just paste. And well, first thing we are going to do is just ping or check everything is okay. Yeah, as you can see, we ping our machine, so we are on the network. Start with the storage pool. Okay.
You know by heart the code that we need to use?
I have here.
And this storage pool code we'll share too.
Yeah.
So what I will do, I will create some examples, and in example, I will create an example directory with examples, and communicate about it in the group.
Okay. So we need at least 2 disks. So first of all, before you install the operating system, you need to go through here and add a new hardware. You can add for example, storage, as you can see, the first one, and yeah, put the space you want, 8
No.
or whatever. I already have 2 more disks. This is the one that that came with the machine, and this 2 disks I added before.
Yeah, the first one is basically the boot disk.
Yeah, yeah, exactly. So, yeah. I hope, yeah, still running. Okay. So first of all, we can check the disk. So CO disk list, and you can see that we have SDC is one of the disks, SDB and SDA. Yeah?
Yeah.
The 3 disks. SDA. Okay. After that, yeah, we are going to keep the disk name in 2 variables. We are going to use only 2 disks for this example. We can use as much as we want, but try to make this easy for the example. So just copy here, yeah. And we are going to take the first one, SDA and SDB.
I'm simply going to get the name.
Yeah. Okay.
Yeah. So
Good.
Yeah.
Yeah. We can check it. This name 0 and is SDA and SD1 is.
But I think you
Yeah.
you mean not these ones. You mean 1 and 2. I don't think it's correct.
Yeah. Well, we
because
can
you're
do it
taking-
also with that ones, but yeah.
I would take 1 and 2. No.
Yeah, we can do it also like that. I tried in both ways, and both works. Yeah, okay.
Otherwise,
2.
we take the boot disk and. Okay, good. Yeah.
Yeah, it's okay. Go to the end. Okay.
Yeah.
Now check it again.
Disk 0 should be B and
Yeah. Still C? Okay.
Because the 0 was not deleted. I guess.
Well, oh yeah. Okay, it's okay. It's just we use these names, so it's okay. That's right. Disk 0 and this one is going to be SDB and SDC. Well,
Really? Shouldn't
Could
be
you check disk name 0?
yeah.
disk name 0 should be B, huh?
Yeah.
Okay.
And disk and the other one.
The other one, I check it
SDC.
Okay.
a bit
good.
on the top.
Okay,
is,
good.
is
Sorry.
SDC.
Yeah.
So we can continue. Then we are going to add the path, the full path to the devices names. Yeah.
Yeah.
You check device path. It's gonna be It's gonna be just that. Okay.
We put it in.
Yeah. And then we are going to keep these 2 devices in another in array for use it in the next command. So first of all, use this. Okay, good. And then we are going to create the storage pool. Huh? First of all, we need to create the file system. So for that, I have this line already done. You can check it on the documentation. Everything, you have much more options. So here I'm going to create the storage pool. I put the label, the name. I choose the devices I want for my storage pool.
And this is striping, by the way. Huh?
Yeah, and this is RAID 0, so it's going to be a striping. Huh?
Yeah.
We have a redundancy here. If we want redundancy, we need to choose RAID 1.
Yeah, then it's
And
copy.
yeah, you have some more examples with another rate. Okay, so hope it works. Yeah, it works. Then we are going to mount. First create a directory on mount folder. Right here, for example. And now mount the storage pool. Huh? So for this, we can choose any device. Huh?
Yeah, and that's where I did make a mistake
So-
the last time. Eh?
Device path, because now both devices are one, so we just choose one of them, and the system know automatically that you are choosing the storage pool. Okay, path 0. Okay.
Yeah.
Good. And then yeah, you can check some. We already have our storage pool. We can check some info about with this command. As you can see, here is the total of the RAID 0. This the two spaces comes together.
So he sees both devices.
Both devices
and
together.
C. Yeah.
And that's it.
Yeah. And then okay, we could upload the file.
Yeah, I didn't do that, but yeah, we can do it.
That's system. CL file system upload file.
This system.
First
give
you
a
need to
command.
touch. We need
Touch file. That's it.
first touch. Well, system is good. System.
Yeah.
And then
Touch.
no.
Between
Between brackets.
Okay. Yeah.
And then touch a file somewhere. Touch a file in the good directory. Touch. Yeah, okay, it should work.
Should work.
Specify maybe the directory. That's
slash file.
Yeah.
So slash make it in my div.
Yeah. Okay. So.
No. Sorry.
Yes, my div.
No. Wait.
It's okay.
No. We are touching. Yeah, it's okay. Yeah, it's okay. Do it like this.
Yeah, my dear slash file.
We are not even doing an upload now.
Yeah.
No, it's just that immediately in the system. What you could do now is do a less or whatever.
Yeah.
Or
So
the other example is that you would do Control Z, create a file locally, and then do an upload. See?
ls and I need to do it get them or
Yeah.
like that.
Maybe you should. Yeah. See, of course,
Slash
Yeah.
ls slash my dear.
the directory. Specify the directory.
But my dear is not there. It's inside mount.
Okay. Go. Okay.
Because
Just create touch in the temp folder.
Yeah.
It's easier.
Yeah.
the three mount to this great.
So maybe we need to touch again under slash mnt slash.
Yeah, touch on
you-
the temp.
Yeah.
Can you go?
Yeah. Yeah.
The touch command.
Yeah. Doesn't work. Huh?
I mean, make it slash mnt slash.
Yeah. Okay. MNT slash whatever. Okay. And then come back here. But,
Okay. File is there.
yeah, so you can see the file is there.
You want to reboot now? Or?
Well, try to reboot. Haven't had a good question, and I'm afraid that we will lose it. And then the question is then how to persist. What are these options and so on. Yeah.
So try to reboot.
Yeah, why not? Well, we know what will happen, of course, because he will basically, you could do it like that, eh?
Yeah. Well, if we go here, Yeah,
It's rebooting.
it's rebooting and installing again. It's taking the image again from my seat.
Yeah.
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 So it's a
It's
new
creating-
kernel again.
Yeah, it's new
Creating a
kernel
new-
again. Yes.
Creating a new image and creating a new virtual machine.
Yeah, actually.
So yeah.
How to persist the file.
Now, yeah, I'll give you the answer to your question. Basically, the real workloads will always run in containers, right? And in virtual machines, and there we will discuss how the persistency works. Right? Because you will want to, you can typically persist state of containers in virtual disks, and virtual disks typically require block storage. And the way we implement block storage is that we use all the nodes in a cluster to have a distributed storage of all the data. Yeah, and that's certainly what we will then cover in the next sessions. Good. Let me go back to the slides. Anyway. So mounting a device, this is basically what was shown by Donato.
Yeah.
Right? To close the session again, just like the previous time, I really invite you to install Docker on your environment. If you do it on Windows, fine. Just make sure that you use and you have the Linux subsystem working, and then you typically can follow the documentation in the URL you see over there. And I'm just including here the steps I did on my machine to basically install the JumpScale 9 environment I have been using during my demo. You will be reusing this quite often, so it's quite important. Now, as you see here, that's the only thing I want to mention. For the gig branch, I specify master here, which is okay today, but we are about to release the 9.1.0 today. That's the plan. If it's not today, it will be Monday. So it's always better to specify 9.1 once it's available. And you can check whether it's available just by going to JumpScale Developer. And if you see the 9.1 appearing, make sure that you specify 9.1.0. I will anyhow update the documentation once I'm 100% sure that you can use that one. Okay, and then the next session is next Tuesday. And then we will really start to show you new things. We'll probably come back also a little bit on what went wrong today or have new information. But we will focus on introducing to you ZeroFS, how it works, how you can persist things in a container locally, but not just locally, but also if you want to persist it in the cluster. And we will show you basically how to create the lists, how to merge lists, and how to boot lists from the hub. And so you create lists, you merge lists, you will upload lists to the hub, and then you will boot containers, actual workloads on the lists. And that's then the basis that we need for then deploying the very most important next workload is the block storage implementation based on lists that you will see. Yeah. So again, this was a session, no strings attached, with things that go wrong, things that go well. Again, I repeat, the idea is most importantly that you do it yourself, that you ask questions, and that going forward we will do less and less ourselves, and it will more like be a lab asking questions. And for sure, I will be involving other people going forward, especially when we get to the more sophisticated stuff. I need to support myself from developers of the key teams, and I'll make sure that I'll invite some of them sometimes so that you can ask questions directly to them during the meetings. So it's always good also to let me know when you have specific questions up front so I can organize that. Voilà, that was it. Do we have questions right now? Is there something that you want to share with us? Let me know. Let us know. Herbert, I've heard you a lot. Arne, you have been talking. Alex, you're bored, I think, because you're already doing virtual machines now. I don't know. Nico, how are you?
I'm okay, man. I'm okay. Everything okay.
Yeah.
Very good presentation, like always. You're spending a lot of time on it. It's much appreciated.
Yeah, you're welcome. For sure, we will want to make things much better yet, but we'll get there. That's clear. We're really focused on making it really great from all perspectives. The people in Cairo, I see a lot of people in Cairo. How are you doing? And Dubai, I see people in Dubai too.
Yeah.
Yeah.
Yeah, we are doing great, and I'm gonna start testing the code today.
Yeah, good. It would be good. What would be nice for us to help. We have been doing a small demo on Kemu, but as you noticed, we used the GUI, the user interface. And from that perspective, it was a little bit like what you would do in VirtualBox, which is nice, which is fine, but it requires, of course, an Ubuntu desktop, which is for most of you not a problem. But then again, I'd rather want to show it all through the command line. So launch a virtual machine through the command line. We have the commands here. We struggle just a little bit still to get it running. We had it running yesterday, but that's something we will finish today.
Yeah.
By the end of today, we make sure that in documentation we provide you the exact comments to do it purely on the command line. So also there, that's my point. If somebody would want to try it themselves and have some input for us, it's very, very welcome. From the question from Herbert, I remember that the persistence, even without containers, is a good question. What if you really want to persist, for instance, the fact that we have been creating a pool or that we have been creating files on a ZeroOS? What are your options? I'd like to answer that more specifically. I already have an idea what the answer will be, because clearly it is not stored. By design, nothing gets stored, but then still the question is then, what are your options if you want to get stored things? And then probably we'll have to talk about block storage. But let's come back to that, Herbert. It was a very, very good question that made me a little bit nervous, but that's good.
That's good.
Nicola, how are you? Nicola, still there? Nicola? No? Okay. Arne, you still have something to share with us? No? Okay. Then,
no, currently not. Thank you, Yves.
No? Okay, perfect. So thank you very much, all of you, again, for all your patience and your attendance. Let's make it even better going forward, and stay tuned and stay connected, and see you soon. Bye.
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 Thank you, Yves.
Bye.
Bye.
Bye.